Hi, everybody, and a very warm welcome. Thank you so much for joining us today. My name is Imelda O'Boyle, and I'm the marketing manager here at NeoDyne. We're really delighted to have you with us for this session on smart manufacturing for specialty chemicals. We know how busy things can be across manufacturing and operations, so we genuinely appreciate you taking the time to be here with us this afternoon. Over the next 30 minutes or so, we'll be sharing some practical insights, real-world examples, and emerging trends around how specialty chemical manufacturers can embrace smarter, more connected ways of working, improving efficiency, resilience, and performance across the plant. Just a couple of quick housekeeping notes before we begin. Today's session is being recorded, and we'll be sending the recording along with all relevant collateral to everyone who registered. So don't worry if you need to step away at any point. We will also hopefully have time for questions at the end, so please feel free to drop your questions in the Q&A or chat as we go along. So now I'm very pleased to be joined by two of my colleagues, Matt and Ash, who will be leading the discussion and sharing their expertise with you. So over to you, Matt.
Thanks, Mel. Let me just take a minute to introduce myself and Ash. So I'm Matt Close. I'm the head of the UK operations for NeoDyne, and I've been with the business for 3 years now. I'm a chartered engineer. I've been in the industry for a long time, let's say 30 plus, and generally system integration side, so delivering to partners. Ash, my colleague, is an MES engineer and leads the team for the UK. He's got over a decade of experience with various MES systems, including bespoke and vendor, such as Opcenter from Siemens. I will run you through the agenda. So we've done the introductions. I'm going to tell you a little bit about NeoDyne, but won't spend too long doing that. And then we'll have a look at the specialty chemical market and some of the challenges that the industry maybe faces. And then I'll hand over to Ash, who can talk you through the Siemens Opcenter execution and the value that will bring and how that addresses some of the challenges that we might highlight. And then we'll have a quick look at some success stories while we're currently working on a specialty chemicals project in the UK at the minute. Unfortunately, it's not one we can discuss, but Siemens have given us some that we can discuss with you and how they address the challenges. And then if we get a chance, we'll move on and answer any questions that you might have. Okay, briefly, NeoDyne, founded in 1988. So it's over 27 years old now, and that started as 1 or 2 people, and we're now growing to a size of over 220. So as you can see, significant growth over that period. We've got 3 business specialisations, which I'll tell you a bit about in a minute. Lots of business customers in a variety of verticals and geographic locations. And we now have 6 offices globally. So while we started the company in Ireland, we now have offices in the UK, Romania, and even the US. So quite a varied geographical reach there. Maybe a differentiator for NeoDyne is our people. Getting good people is really hard, especially in the STEM industry, as I'm sure you can all imagine. So we tend to take a lot of graduates, degree qualified, or now apprentices as well. And we take permanent staff rather than using contract. So the key there is that we take people, grow, train, give them a career and progression. And that can be backed up by the fact that the 7 directors that run the company now all started as graduates at NeoDyne some time ago. Continuous learning gives people the confidence that they've got a career in NeoDyne and giving them that career path. So our retention's quite good. That gives us a lot of skill sets. And fundamentally, if we get the right people in the business, then the customers get looked after correctly, which is the key. Business specialisations. So there's 3 areas of the business that we try and generally split it into. There's integration and digital manufacturing, which is where we'll predominantly be discussing today, and that's where our MES team sits. So we've got well over 15 engineers that are full-time MES involved in the digital manufacturing sector, but we also do industrial controls, cybersecurity and safety, machine safety within that sector. The other areas of the business, which probably aren't quite as relevant to today's discussion, power gen and energy systems, transmission and distribution. How does that relate to the verticals? Traditionally, and if you look back over the time, the digital manufacturing look after things like pharmaceutical, medical devices, food and bev, consumer packaging and specialty chemicals. That's not exclusive. We do other work, but if you look across the history that we have, then those come to the surface. The energy and data centers is more about the power generation sector, as well as renewables, and T&D do very similar verticals to the power. So focusing more on the specialty chemicals, that's more in the digital manufacturing. Where do we work? As you can see from there, the diagram shows that we're pretty worldwide. Certainly within the MES, we're currently supporting factories in diverse locations as Brazil, Singapore, Calcutta on an ongoing basis. So we've got a very wide reach there, and I think within the MES, MOS field, you're more than able to do that from anywhere. Okay, so that probably covers a brief overview of NeoDyne. If you're interested in anything we've got to offer, not necessarily in the MES, MOM, then do get in touch. I can certainly put you in contact with the right people. Let's move on to some industry trends in the specialty chemicals and maybe some challenges that the industry faces. So critical industry trends here. Navigating market volatility, 50% energy increase in prices, and that's obviously been reflected for a number of reasons over the past few years, but is expected to continue to do so as well. On top of that, companies are trying to execute on a net zero, so there's a 45% reduction in emissions required to meet the 2050 goal, and on top of that, general energy usage across the globe is increasing, so the demand for energy consumption is going up and up. Now, while there's a thread there, you can see that when you take those in compound, then that only exaggerates the issues that the industry faces. Moving on to what's driving the need for change, there's a number of factors here that we've highlighted, and it's by no means exhaustive, but certainly in this industry, individualized production is becoming more and more predominant and an expectation of the end user. So growing individualized production demand, that agile requirement to react to it, and managing the material flow because of that. Digital disruption, everyone's talking about it. How can people use the advances in the digital systems to move things forward? It does impact time to market if it's inconsistent or siloed, which is often the case with legacy systems. And this gives a high complexity of the interoperability of the systems. Localization, a term I only recently learned. So this is the need to make both global and local requirements, and both from a technology and a labour perspective, and how complex that supply chain is and how easy it is to disrupt that. And I think recent events, or maybe not so recent now, but the pandemic and the like have very adequately illustrated how heavily that can impact businesses. And finally, EHS standards. They're ever increasing, and they are different around the world, but companies that are not in one location have an obligation to meet all of those, and it reflects heavily on the company. Different material flows and production sites have different requirements, but ultimately the companies want to meet all of those. Briefly, this slide sort of highlights the fact that the sector is growing. It's also a significant sector within the UK, certainly the third largest there, and it's continued to do so, continuing to look like that market will grow significantly over the coming period. Technology trends, raw material trends, and regulatory trends are all having an impact, and that also affects the end use trends as well. Okay, so that highlights some of the challenges that the industry faces. What I'll do is hand over to Ash, who is our lead MES engineer in the UK, and he'll walk you through some of the advantages that Opcenter can bring and how that can address the challenges that you may face. Thanks, Ash.
Thanks for that, Matt. So Matt's just gone through talking about the pressures specialty chemical manufacturers face, which include a bunch of factors such as cost, compliance, complexity, sustainability. But the real challenge is that most plants are still trying to manage execution using a mix of ERP screens, emails, spreadsheets, disconnected systems. This is where manufacturing operations management comes in, and Siemens Opcenter is Siemens Enterprise platform purpose-built for complex industries such as chemicals. So when we walk into chemical plants, the same problems come up again and again. ERP plans production, but the shop floor lives in reality. Operators rely on paper, spreadsheets, and tribal knowledge. Materials get misused, changeovers take longer than expected, quality issues appear too late, and management only sees performance after the fact. What MOM/MES does is connect planning to execution in real time. It ensures the right material, right equipment, right process, every batch, every time. It turns raw production data into KPIs that operations and leadership can actually act upon. So I guess we can think of digital manufacturing as three layers. ERP is great at planning and transactions. PLM handles product and process design, but neither of them actually runs production. MOM sits in the center and orchestrates execution on the shop floor. It schedules work orders, enforces resources, captures quality, tracks the materials, and connects automation systems back to the business systems. So I guess this is like a brief overview of different systems used to manage manufacturing operations in the current landscape. MES isn't a novel concept. It has been around for years, but many projects failed or become overly complex. And I guess some of the reasons could be heavy customization, long deployment periods, poor user adoption, lack of management buy-in, just to state out a few. That's exactly why Siemens built Opcenter as a modular, low-code, scalable platform to reduce complexity and accelerate time to value. I guess we'll be going through the portfolio overview which Siemens Opcenter provides. So Opcenter isn't a single MES module, it's a full manufacturing operations portfolio. Modular applications, industry templates, for process manufacturing, in particular, native integration, cloud ready, and designed to scale from one plant to global operations. This portfolio is built as modular but fully connected digital manufacturing as the backbone. MES sits at the core, executing and controlling production, while the other modules support areas like logistics, planning, quality, analytics, and so on. When everything works together, you get a real-time, closed-loop manufacturing operation fully aligned with ERP and automation systems. So this is a typical specialty chemical operation, from raw material reception to tank farms, batch and continuous production, packaging, and warehouse distribution. Opcenter sits across this entire value chain, not just production, but logistics, quality, and material flow. So instead of islands of automation, you get one orchestrated digital manufacturing layer. So these are, I guess, the main pillars what the Opcenter solution portfolio delivers. And I guess there are 7 pillars, and we'll go through each of them in detail. But I guess the vertical integration is a common theme across the different components. It synchronizes ERP and manufacturing. So again, these are some of the communication standards which Siemens provides out of the box. I guess a few of you can recognize some of these file formats, but again, depends on the business and the need. The drivers exist, which can cater for easy integration. So I guess the first component I'm going to talk about is the APS, Advanced Planning and Scheduling. So production plans are defined at the business level, and the way it's distributed to the shop floor is via this component. Scheduling is a part of vertical integration because when we download production orders from ERP to MES, these are sequenced and assigned to the right equipments to increase the efficiency of the resource utilization. The vertical integration also works the way back from the process into the ERP to deliver exact shop floor data about, for example, material quantities, so that ERP has a reliable feedback on how actual orders have been carried out. This is just to give you a look and feel of the Opcenter APS module. Again, a bunch of simulations can be done, and plans can be made, which can be reflected back into MES via the integration methods I already touched upon. So the next component is the horizontal integration and process orchestration module, which synchronizes systems, automation, and operator tasks throughout the different areas and processes to reduce errors and cost of manufacturing. So these are a bunch of slides to show you the out-of-the-box UIs, and the operator, I guess, goes into specific screens based on the operation or functionality he's trying to perform at that point of time. I guess the next component I'd like to talk about is integrated quality, which is, again, an important cog in the whole MES landscape. So execution goes hand in hand with quality. Siemens enables at-line and offline quality execution so that the right quality tests are performed at the proper point in time and results are always associated to the tested materials. So the lab management solution contains several integrated components. I'm not going to go through each of them, but I guess you can get the gist. There's a component just to manage the creation and of samples in a structured way. There's a component to manage the execution of these tests performed in the lab or external labs. There's a reporting component, which again makes it possible to analyze, and higher management gets to see the real picture. All the components work together and seamlessly support the management of lab activities. So the next component is the production reporting, which allows a detailed visibility on production performance based on data collected in real time from all the production processes. So again, this is OEE listed here, but I guess the next slide is also, yeah, bunch. So the idea is we have a bunch of inherent reporting tools with configurable UIs, which can be used to drill down, analyze, get to the bottom of what the actual issue is. And also, I guess, yeah, it's platform independent so that the data can be coming from all different sources and it can all be utilized via these reporting tools. So the next bit is the material genealogy bit, which in essence is forward and backward traceability. This enables to perform efficiently a product recall if necessary due to any customer complaints, and also enables manufacturer to track and show the quality of the produced finished good. Here again is an example of traceability of materials. So you can see a certain material, all the operations it has been part of, and the different raw materials used to make up that finished good. And the last bit is the manufacturing intelligence, which gives you full visibility on the process, aggregates data from all these different sources, and transforms them into KPIs, which people actually care about. So manufacturing intelligence can be applied to one single site, but can also be applied in a scalable solution to several sites. Such visibility usually allows you to detect the root cause of issues and also supports the continuous improvement of manufacturing. On top of this digital foundation, Siemens is layering AI for predictive quality, automated root cause analysis, and also some kind of smart engineering assistance. The key point is you can't do AI without clean, contextualized manufacturing data, and that's exactly what MOM provides. So just to finish it off, I guess some highlights. So when manufacturers implement a solution such as Opcenter, the results are very practical. Higher efficiency, better quality, regulatory compliance, and so on. This isn't about just IT transformation, it's about continuous operational excellence. So I think, yeah, that covers all the bits I need to talk about. I'll pass it back to Matt to talk about some success stories with Opcenter.
That's great. Thank Ash. That gives us a good overview of the details that Opcenter and can provide, and also the challenges it can overcome. If you've got any more detailed queries, then either drop them in the chat or we'll catch up with you afterwards and answer those more specific queries. Just before we close, what I said before, that while we're working on a current live project in the UK in this sector, unfortunately it's not one we're able to discuss, but what we can highlight is a couple of success stories from Siemens themselves. So the first couple are with BASF and cover some slightly different challenges. So in the first one, the lacking that overall process transparency and potential sources of error due to paper processes and the errors that can bring into the system. And this is in BASF in Germany, with obviously significant industry. They implemented a modern MES on Opcenter to collect and handle the data automatically and digitally, which meant they were eliminating print orders, and that achieved a paperless process. It was implemented using PCS 7, and that really did reduce the project risks and was successful in increasing the improved process transparency. A similar challenge with BASF was more around the LIMS, the lab and manufacturing and the quality, very consuming manual production procedure, and caused compliance issues with regards to deviations. So again, trying to go paperless, significant revenue, it's a 59 billion company. And the solution there was integrated batch, shop floor and LIMS, all implemented via Opcenter and PCS 7, but with semantic batch as well. And that increased the overall efficiency and data maturity, which reduced issues with regards to the LIMS and quality. Finally, a smaller company, and one that's still in the specialty chemicals, in the paint industry, Koba in Central and Eastern Europe. They had significant issue with regards to non-conformities and improving the customer satisfaction. They noticed a 70% decrease in product non-conformity reports, which obviously is a significant saving, and hugely improved their customer experience and satisfaction. So if any of those examples are of interest or you have questions, then do get in touch, either via myself or Mel. You can contact either Ash or myself on LinkedIn, or through the company website. I'd like to thank everyone for attending. Hopefully it was useful and informative. Thanks to Ash and Mel for providing us with those slides, and hopefully speak to you again. Thank you very much for your time. I will now close the event.